Okay, I already share. This is chapter 1. Okay, this is chapter 2. Okay. I think we are here yesterday. Can you hear me, right?
Yes, Doctor.
Okay. Mhm. Um, I think we are here yesterday. Okay. So as I said yesterday, this is fatigue result. This is fatigue result. Fatigue in Malay we call it as lesu. Okay, lesu. Okay, when you do the fatigue test, okay, fatigue test is the test in which that you give load, and this load is given repeatedly. I am not happy. I'm not happy with my pen. It's okay lah. I will try to do without. Um, okay, you give load, and then this load is given repeatedly. Okay, for example, the application in real life is chair. Okay, you have chair, and then chair is the thing that we use repeatedly. So people will sit on the chair and then load, unload. Okay, and another example is bridge. Okay, bridge, you have cars or vehicles passing through the bridge. So when the car is on the bridge, it is load. When it is not on the bridge, it is unload. So that is why fatigue is important, because we want to measure how many times that thing can be that thing can that product or that thing can stand with load, how many repeated times. Okay, so if the load that you give to that object does not reach the fatigue limit, does not reach the fatigue, does not reach the load in which that it will be broken, so that 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 product or that object or that bridge or whatsoever can last forever. Can last forever. For example, you make a chair. You make a chair, and then the maximum load that this chair can support is 100 kilogram. Okay, so if when you use the chair, the person who will sit this chair, who will sit on this chair, the load is less than 100 kilogram. For example, maybe 50 kilogram only. This chair will not fail. This chair will not fail. Okay, but if the load that you give to the chair, probably 100 kilogram, it will have certain amount of number of cycle that it can last. Okay, if you do the test, you will get a graph like this. For example, okay, this one is steel, this one is aluminium. So if the chair that you make was produced using aluminium, so if you give load at 280 MPa, so the number of cycle that it can last is here. So beyond, after this number, this the chair will fail. If you give load at for example 140, the chair can last until this value, until this cycle repetition time. Faham tak? How many times that you can use that chair? How many times people can sit on it? Okay. So, but if the load is only 70, your chair will last forever because it does not meet this graph. So, and with steel, similarly with steel, if you give a 280 MPa, so the chair can last up to this number of cycle. I'm not sure if you understand what is the meaning of number of cycle, but I hope you understand. Number of cycle mean n. N means how many times it can be used. That is number of cycle. How many times it can be used. Okay. So 280 10 to the power of 5. And if you give the load 210 MPa, the chair that you make using steel can last forever. Okay, so this SN graph is stress and number of cycle. So deformation under axial loading. Okay, so when you give force to this cylinder, to this rod down here, P, this rod will elongate. So this is the elongation. And this elongation, I think this is delta. Okay, this is the change in term in the length, which is delta. This one. Okay. Okay. From Hooke law, now we want to derive this equation. How this equation appear like this. So from Hooke law, we know that E is equal to stress over strain. So stress is equal to E times strain. So you get this one. Okay. And from this equation also, you know that strain can be written. So I'm not happy with my pen. I think maybe I should. Yeah, try again. So strain, this strain also can be written as stress over elastic modulus. Okay, and you know that in the previous chapter, this stress is equal to E over A. So this will be equal to P over A. This strain lah, over E. So when you simplify this equation, it will become P over A E. So you get this one. Definition of strain, you know that strain is equal to LF minus L original divided by L original. Or this one can be written as delta. So this one is delta, and this one is L or L naught, L or L naught lah. So this one is this one. Okay. So and then this one and this one are the same thing. Okay, are the same thing. So when this one and this one are the same thing, this means this one and this one also the same thing. So strain is equal to strain. Which one? This one and this one. Delta over L equal to P over A E. Okay, so this one L, you can bring to the right side, so you will get delta equal to P L over A E. Faham tak? So you get this one. Faham ke?
Faham, sir. Faham.
Okay, actually, I'm not happy with my pen today. Probably because last night I didn't shut down my laptop. I didn't shut down my laptop, so it becomes like this. Hmm. Can you wait me 5 minutes? Can you wait me 5 minutes? I restart my laptop. I have to leave the chat a little bit.
Okay, sir.
No, I cannot. No, I don't want to. No, I cannot end the meeting because it will be very complicated. So it will be recorded. Let me try again. Okay, so you will get. Okay, so this is for this case. This delta. Okay, this is for this case. PL over AE. So in which that P is the force, P is the force, L is the length, A is the area. Area for rod is pi r square, and E is the value of elastic modulus, the value of modulus of elasticity. Okay, so when you have variation in loading, cross section or material properties. Okay, for example, you have this. Okay, this is your wall. This is your rod. This is your first rod, and then you have another rod with another diameter made from different types of material. When you pull with a force, so the question asks you, what is the value of deformation or the value of deflection or uh, delta lah. Okay, so this one is material one. Material one that means it will have its own value of E. So E1. This one will have its own value of E2 of elastic modulus of its own elastic modulus, and then the length will be could be the same or could be different as well. So is the this is the symbol of the total summation lah. So I is the number of cross section or number of variation in loading. So this for this case you have I equal to 2. So this delta the this delta, to solve the problem you have to add P1 L1 over A1 E1 plus P2 L2 over A2 E2 because it has two things. Faham tak? So that is why you have this symbol for this equation. When you have variation in loading or cross section or material or you is made of from different material. Faham tak?
Betul.
Mm-hmm.
I itu apa?
I itu number of variation. For example, this one, the number of variation only one. Only one. For this one, the number of variation is 2. Because this one you have two types of material and two types of length. So if you have another cylinder in front, so this is 3. So this one I equal to 3.
Oh, faham. Okay.
Okay, another question? Any other question? So in this slide, we are looking for deformation. So deformation is delta. Delta. Tak, delta. Delta deformation lah. So the equation is PL over AE. I think you have met this equation before. Any other question? If you don't understand, you tell me if you don't understand. Okay, if you understand, it's okay. I think I don't want to proceed with this lecture today because it is annoying that my laptop has becoming like this. So I think maybe we continue next week. Okay, I will try to figure out what happened. Okay, have a good day.
Okay, thank you.
Okay, sir.
Yes, sir.
Thank you.